Professor Pelton. This is Algebra 2, Chapter 6, Section 2. This is part 2 of the video. So now we're going to do some operations involving E, Euler's number. So what you have to keep in mind is E is just like X, Y, or Z. It's just another variable, except this variable represents a singular number. So it's not variable, it's a constant, okay? But you can treat it like a variable. So this is a power of a product. Oops. Okay. Oh, product to power, sorry. So this is adding, so this is e to the ninth. Welcome. So if you don't know your exponent properties, go back to pre-algebra, algebra 1, and prior chapters of algebra 2. And the last chapter, review your exponent properties, right? Because again, you can write these out longhand if you want. And you get 9 e's because they're all to the first power. If you wrote it out longhand, if for some reason you didn't know your exponent or your power rules or exponent properties after this many years. Okay, next one's a quotient rule. 16 divided by 4 is 4. This is e to the 5 minus 1. It says subtract exponents. That's the rule for quotient. So that's e to the 4. Okay. All right, next one. So this 2 is the power of a product, so it goes to everything. That's really a 1 right there, because everything it does has an exponent. It's a 1 as a placeholder value if it's not written. So that's 3 to the 2 times e to the negative 8x, because the power to power rule says multiply. So that's 9 times e to the negative 8x. Negative exponent property says put it on the bottom, so it's 9 over e to the 8x. Because again, you can't have in any chapter negative exponents in the final answer. Okay, next one, 4 through to 16. So we've done these before, but now we're just adding an e. So 16 is 2, 2, 2, 2, right? 4 times 4 is 16. And e to the 20 can be broken up into e to the 4x times 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 e to the 4x. So why is that? Well, 4 plus 4 plus 4 plus 4 plus 4 is 20, right? 5 fours. Why did I break it up in groups of 4? Well, the index is 4. So I have a 1 group of 4, 2 groups of 4, 3 groups of 4, 4 groups of 4, 5 groups of 4, 6 groups of 4. So I get 2e to the x, e to the x, e to the x, e to the x, e to the x, right? And there's nothing left inside. So this is a perfect radical for a final answer of 2e to the 5x. Okay, so you can do the numbers like normal. You can also look at this and go, well, I'm breaking this up with an index of 4. So 20 divided by 4 gives me 5. So there's a couple ways to go about that without having to write it out like that, but it's up to you as to what you need. All right, pause the video, try the student problems for yourself. Okay, this one is a product rule of powers, exponents, right? So it's e to the 11th, you just add them. The next one, quotient rule, 24 divided by 8 is 3. So this is E8 minus 5, or 3e to the third using the quotient rule. Move this down. Remember, if there's no power specified, no exponent specified, you can put a 1 in there because it's a placeholder. So this is power to power rule or power of a product, 10 to the 3 times e to the negative 9x, or 10 to the 3 over e to the 9x, because you must have no negative exponents in the final solution. So you use the negative exponent property, put it on the bottom, which gives me 1000 e to the 9x for our final answer simplified. All right, next one. If there's no index specified, it must be a 2. So this is the square root of 3 times 3, and you can write them out if you want to. All right, I think I got it out, right? So that adds up to 12. So I ended up getting a group of 3's out of here. So that gives them the 3. And then 1, 2, 3, 4, 5, 6. I got that right. I mess up? I think I might have. 2, 4, 6, 8, 10, 12. Nope, I got that right. So it's 3 e to the 6x, or you can see simply 12 divided by 2 is 6, right? Because essentially what you have is the square root of e square root of e to the 2x, or the square root of e to the x squared, right? So they would cancel, leaving with e to the x. Because essentially you have e to the x times e to the x, or two of them. But we don't want to write out 12 e to the x's. It's easier to put in groups of two. Or just do the division rule trick. Okay, page 4. Okay, so the last formula of all the formulas in this chapter is the compound interest formula. So if you think back to formulas that we've done, the standard exponential function is y equals a times b to the x. And if you do the um, rate version, it's the y equals a 1 plus, ah, there we go, 1 plus r to the t. And if we have any compound interest, it's a equals p 1 plus r over n to the nt. So those are the three we've done so far in the chapter. The first one being the very basic one. The second one is when you modify b to include percentages. And the third one is when you have percentages and compounds. So the last formula we're going to do is the a equals pert, or p times e to the rt, is when you have compound continuous interest, or continuous compounding. So uh, when you have that, is the form you need to use. So you need to use one of these four for word problems, basically. So based on what you have is the one you need. So you invest $8,000 in an account for 6 years. So that's your principal amount. So A equals 8,000 times E. Well, how do I know this is an E1? Because it says compounded continuously. It's 7%, so 0.07, and T is 6 years. So A is approximately $12,175.69. And again, order of operations is very important in this also. So make sure when you're using the calculator, use it appropriately, otherwise you get ridiculous answers. So exponents have to come before multiply. So let's look at the calculator really quickly. So if we're going to do this problem, it's going to be your E and your 0.07 times 6. Oops, that's not E, that's natural log, I'm sorry. There we go, same button usually. And that was the 0.07 times 6. Okay, so the thing is don't round, and don't round, times 8,000. And we got our answer that we had to, of course, round to get what I gave you. Because the thing, when you're in thousands and tens of thousands and millions where these problems are, any rounding whatsoever is going to throw it way, way off. All right, pause the video, try the student problem. Okay, so this is a loss problem. So the amount, the original principal is 5,000. We want to know the final amount, A. So E, we're losing 2.5% over 3 years. So it should be less than $5,000. So it's going to be approximate. So again, do the exponent first, the power, and then multiply by the 5,000. And don't round, don't round, don't round. $4,638.72 should be your answer after you're all done there. Okay, let's take a look at the examples now. So if I was looking at one of these formulas, what am I actually reading? So what is the 4,500? That is the principal amount, or it's the starting amount, however you want to think about it. When you take a loan, the starting amount is the principal amount. Because if you buy a house for 400,000, you don't pay 400,000. You pay much more of that with interest. And that's the final amount you pay. So what's the 0.04? That is the 4% growth interest rate. Okay. Is this growing or shrinking? Well, that's a positive 0.04. So this is in fact growth, because 0.04 is greater than 0, right? Not negative. After 10 years, how much will be in your account? Well, you're going to have to do A equals 4,500 times e to the 0.04 times the 10. And you're not going to get an exact amount, of course. You have to do some rounding, 6713 and 21 cents. Okay, pause the video, try the student problem. What is the 4250? That is the principal amount, or the original amount of the loan. What does the 0.035 represent? That represents 3.5% loss. This is clearly shrinking because negative 0.035 is less than 0. Okay, all the negative ones are decay for the E. How much will be in your account after 10 years? Well, the amount in your account is going to be 4250 times that E to the negative 0.035 times 10 years. Do the exponent first, then multiply. You'll have approximately, $2,994.92. Okay, that is approximate. And that is the end of part 2.